Hello, everybody, and welcome to the Keyfactor Talk IoT Cybersecurity. Today, I want to talk a little bit about the role of the PKI in the OT networks, and we are focusing on protocols, implementation, and also on the hierarchies that we need when we are talking about PKI. My name is Andreas Philipp. I'm a senior business developer in the IoT department at Keyfactor. I'm around about 30 years in the cybersecurity market and business in several roles of starting from as a developer and also managing some business unit itself. So let's have a look on the agenda for today. So in the next 20-25 minutes, I will talk a little bit about OT networks and the usage of X509 digital identities, and also the usage and the implementation of PKI itself. Based on that, I will jump into the OPC UA protocol stack and talk about the usage of certificates, X509 certificates in OPC UA. And then later on, I will talk about the usage or the implementation of PKI in OPC UA. And followed and finished with an outlook, what's coming up and what we see as trends and in the market and also in this network itself. Some words about Keyfactor before we start. So we at Keyfactor, our mission is to build a connected society rooted in trust with identity-first security and for every machine and every human itself. We have a broad portfolio underpinned of our open source solution, EJBCA, the community version, and Science Server community version. Plus, we are supporting the Bouncy Castle Java crypto library itself. So based on this technology, we developed several kind of solution. One is our flagship, the Keyfactor EJBCA PKI solution that is used in various installation and setups. And then comes the certificate lifecycle management solution, our Keyfactor Command and Keyfactor Command for IoT. And last but not least, we are also offering signing solutions, Keyfactor Sign Server and Keyfactor Signature. All of these product ranges you can consume either on premises as a hardware appliance or a software appliance or in a cloud as a pure cloud environment, but also as a service offering. You find us in this environment itself. So that's the underpin. So in the end of the day, and to see the law of the instrument, for us, everything is a digital identity, and that is something that we have to manage. And of course, when we are looking into the OT network, and then we see also the transformation over the last 5-6 years. So, and I'm working in the OT space for around about now 10 years at Keyfactor. I saw all trends. So I started also with the typical standard traditional ISO pyramid that is well established in the OT environment, and that's on the left side. You see the field level, the control level, the process level, and then we are changing or we are going up into the IT space where we have the management level and the enterprise level. And with the introduction of concept like Industry 4.0 and the so-called digitalization that we see, or the industrial IoT that were introduced into this pyramid, into this concept. We see that we are now talking, or we are step by step now talking about a mesh of communication on a factory level with a different kind of products, sensors, actors, devices. And we are going up into the enterprise environment, and we are going up into cloud applications. That is a natural transformation, and that's a huge driver OT market now, and also for the companies and business which are working into this space. Yeah. And this digital transformation, what we also see that we have that also the protocol stacks that are established in this technology and in this networking environment also has to be transferred into the new digitalized mesh transformation network itself. And so on the field level, on the control level, there are very established and very clearly established sometimes also real-time protocols that we don't touch today, like a Profibus, like the IO linker. That is something we don't touch. And we don't address when we are talking about cybersecurity, because that's on this level. But when we are going up into the Ethernet-driven protocols, like Profinet, Ethernet IP, OPC UA, or going up into the REST, HTTP, Modbus, MQTT. All of these protocols, sometimes some of them were introduced over the last years, some of them were been around for ages, like OPC, but with the expansion of the UA, the Unified Automation, we see that they also address this digital transformation. But all of them are using mechanisms and security mechanisms to, in the end of the day, to establish a confidential, integer and authenticated communication channel. And here, when we talk about PKI and digital identities in the OT network, we talk in general about functionality of network authentication, secure Ethernet communication via HTTPS, TLS, so usage by OPC UA, MQTT, or other protocols. We talk about remote services. We talk about digital twins, software update, SBOM, secure boot, firmware update. All of these mechanisms are driven and are underpinned on a trust level by PKI and digital identities, independent of the protocol stack, independent of the communication direction and the communication partner itself. So, but to pick up an example and to talk in depth about the usage of identities and X509 certificate and also about PKI, let's have a deeper look into OPC UA. So OPC UA started with a huge claim, security built in. So what they did, they understood the necessity of a confidential and integer communication channel, where they can transport all the different kind of parameters and communication and communication messages, and they built in a complete security framework into their specification framework itself. So, and PKI and X509 certificates are, let me say precisely, the X509 certificates are a significant building block in an OPC UA protocol stack itself. So, first of all, OPC UA and X509 certificates. OPC UA has a layered embedded security architecture. That means we have the transport layer security, and there is a typo in my presentation. Sorry. and the application layer security. It's not the transport layer security as we see it here on the graphic on the right side here. So on the top level, it's the transport layer security, and down we have the application layer security. And that is a principle that you have to bear in your mind when you're talking about the usage of X509 certificate in OPC UA, that you have this different kind of layers built in. On the transport layer security, X509 certificates are used for confidentiality, integrity, and application authentication. That is one of the key security mechanisms in OPC UA, that on the transport layer security, X509 exclusively are used for the security itself. On the application layer security, we see mechanisms and security features like user authentication, user authorization, auditing, and availability. And there, not only or exclusively X509 certificates are not used. Here we also see JSON Web Tokens, OAuth2 mechanisms, and other or symmetric functional or symmetric key crypto. That is something that we see on this level here. But on the transport layer security, X509 is exclusively. And that's a built-in into the framework itself. I don't want to dive now deeper into the mechanism of OPC UA. That is something that you can see and that you can the usage of X509 certificates. That is, in the end of the day, the principle of how to secure communication, how to derive and to generate the session key for a secure layer communication. That are the basics of crypto, of applied cryptography. That is something that we don't see. But in addition, OPC UA sees also, the foundation itself sees also the necessity of advanced mechanism that has to be provided by the protocol stack and by the specification. For example, the secure update, software update mechanism as an add-on or an add-in that is specified in part 100 of the specification framework, or the global discovery service, the GDS. So specified and designed in, or specified in part 12 of the OPC UA specification, where the global discovery server implement a central service for discovery and secure management, including X509 certificate. In the end of the day, we are talking about the built-in certificate lifecycle management directly into the protocol stack via the global discovery service. So the GDS is responsible for providing or issuing certificate, renewal certificate, alerting when an issuing is going to expire. That are the core functionalities. And last but not least, we also see with part 21, secure onboarding, that is addressing the life cycle of a device to verify the authentication when it's joining a network, when it's joining an OPC UA network itself. So that you are onboarding components into your network by using a security mechanism specified in part 21 to proven the authenticity of the device, proven the origin of the device, and to have establish a secure onboarding mechanism. And that is specific for OPC UA, and from my point of view, I think it's very comprehensive and very powerful specification framework, and also very complex, to be honest. It's definitely a very complex thing to implement, to manage, to part, but step by step, we are seeing now also into the market that GDS functionality is introduced, that first onboarding mechanisms are being introduced. Yeah, and all of this security, X509 based security mechanisms are now step by step are introducing into the market, into the devices, into the software stacks and itself. And that brings me to the next point, is that first of all, we talk about the usage of X509 and OPC UA. Now let's look at OPC UA and PKI, because that's another thing. So usage of X509, it's very often done by using an OpenSSL library and generating your self-signed certificates, and then you're deploying these into the stacks, into the protocol stacks of OPC UA, and you are using it. These X5 self-signed, unmanaged, not trusted X509 self-signed certificates. But what we see also as a vendor of a PKI technology is that step by step now, companies are starting also introducing the PKI into the OT networks itself. So starting from the company level, where you have the corporate PKI with the root, with the issuing, intermediate, all the hierarchies and the flavors you can see here. Yeah. So for the operational side, for the device identity side, you have different kind of CA and different kind of hierarchy lines that you can establish them. Yeah. Sometimes it is a starting point, but on the other hand, we also have the starting point that on the factory level, the CAs are introduced, and that which has to be connected to a root. And also here on the factory level, we have also operational certificate issuing instance. We have device issuing instance and CAs that are operating on this level. And of course, we have also validation services provided for CRLs, for OPC, OCSP, but normally as a CRL distribution point are established on this factory level. And then we are going down into the field level. And here we need functionality like product line RAs, CAs, so issuing certificates during production to a device. Managing or issuing transport layer security certificates on demand, renewing this. You have to adapt an online or offline concept, because sometimes you cannot be online or you cannot be connected to your factory level, or other levels with your CAs that you are operating on field level, because of your network segmentation, because you're not allowed to communicate into other network outside your OT environment. But also there you need also validation service for advanced secure onboarding mechanism, for the GDS implementation on the OPC level. And that is today the idle world. That's the idle world that we see. But also there, the blue lines, that is something that we see that step by step now being introduced. But on the orange red lines, there are huge question mark today. But there is light on the horizon. And so looking and talking about our experience here. So also on the red level, we see now step-by-step technology and products are introduced to solve the last mile problem and the last point problem in combination with libraries, protocol libraries from OPC UA who has been released and who are supporting with the GDS now X509 and PKI usage. We see also that companies like Siemens, for example, they introduced their Scenic RA. I think it's in April, end of April, at the OPC UA Security Summit. We saw a presentation from the Siemens department where they introduced this Scenic RA. That's on the field level a component which is responsible for issuing certificates, for connecting to a GDS from an OPC UA network, and also in advance, I think they will also address the onboarding mechanisms. Trusted Object, one of our partners, who has on a field level component, an RA component, and also an offline RCA component that are providing certificate during the production lifecycle. And they are addressing the on and offline concepts that has to be in place when we talk on field level. And last but not least, let me talk about the TrustPoint project, where we started together with several kind of companies here in Germany, where the goal is to develop an open source stack that is running on a field level and providing PKI mechanisms for secure onboarding, for connecting and providing certificates for OPC UA network and for other networks. And in this project, we are supporting the OPC UA protocols. We are supporting in advance other onboarding mechanisms like from the IEEE. And we are providing also an online and offline PKI solution so that you have the flexibility to establish a trust domain or to establish trusted domains on the field level itself. That brings me to the end of our webinar today, and so we will see that, or we saw over the last years, that PKI is becoming an essential security component in the OT network. One driver is the trust that has to be established. One driver is the digitalization in this environment. Another driver is all the compliance and regulations that are coming up now with NIS2, with CRA, with machinery directive, and the usage of ISO 62443 frameworks. That are a huge driver, and PKI here is an essential security component and is step by step now introduced into the OT networks itself on the factory level, on the factory level. Beside this, we also see that we need advanced solutions that are meeting the application or the OT specific requirements. As I mentioned, so OPC UA has a certificate lifecycle management built in based on the GDS. They don't need any lifecycle management that we know from our established IT world. And you cannot handle something with agents that are running on the client side because you're not allowed, or you cannot install something on a PLC. So therefore, we need dedicated solutions like the Xenic RA from Siemens that were introduced now, or a trusted object or trust pointer. That are typical solutions. And for my prediction is that we see over the next years that are step-by-step new products and new concepts will be established, but also new challenges will be occur, and that we have to adapt to our processes and our workflows that we are established, especially in the OT world. One is the expiry certificate that we see also today with the self-signed certificate. We see also very often that certificates are expired because they are not managed. But how do we handle it when we have now an alert, and how to do an auto update of a certificate? These are all questions that have to be answered. But I think the point is, and that is one key point of my presentation, is that PKI has entered the OT network. It is an essential part, and we have to start implementing the PKI also on the factory level, while on the field level now, step by step, new products, new technologies, protocols, standards will be established. And to meet the requirements over the next years and decades, the security requirements, PKI is an essential part. That brings me to the end. here are my contact details. If you have any specific question about this, please don't hesitate to contact me. I also can provide you the link to TrustPoint, but for sure you will find it if you Google it. You see the process stack itself. And thank you for your attention for today. And if any questions popping up, please contact me.